In the last module, I showed you how to add an orchestration to your project and how to begin development by defining variables and then by adding shapes to the design surface. And that was a good start, but we could hardly say that that was sufficient to automate a business process. So in this module, I will show you some of the other shapes in the Orchestration Designer toolbox that you can use to increase the functionality of your applications. In the first lesson of this module, I will show you a series of shapes that you can use, and they will allow you to organize your orchestrations and control the flow of processing. In the second lesson, I'll show you how to handle some common scenarios that you'll encounter while developing your own orchestrations. In that, I will show you how to access fields from a message body, how to make calls to a .NET object, how to accept a response to a message that was sent out earlier in the business process, and finally, I'll show you how to implement exception handling. So the orchestration that we created in the last module simply executed from top to bottom. It received a sales order message, it transformed that to a restock message, and then it sent the restock message out. And then the orchestration ended. And it would certainly be nice if all business processes were that simple, but we obviously need to be able to handle more complex scenarios if we're ever going to automate a real business process. So while an orchestration is executing, it is typically going to need to examine one or more fields of a message, and then it is going to make some sort of a decision based on the values that it finds. And then some particular branch of the process will execute based on the result of that decision. In this lesson, I will show you a set of orchestration shapes that you can use to evaluate expressions, to make decisions, to control the flow, and even to terminate the orchestration if your business process's conditions require it. Making use of expressions within an orchestration is particularly powerful since you can call out to .NET classes, including classes of your own assemblies. I will also introduce the exception shape, and finally I will show you two shapes that allow you to invoke one orchestration from another. So as your orchestrations grow more complex, you will probably want to start grouping sets of shapes together, if for no other reason, at least to make it easier to find your way around. Now there are two shapes that can help you with this. There is the scope shape and there is the group shape. Now the group shape is the simpler of the two. It has no runtime behavior associated with it. You simply drag a group shape onto the design surface of your orchestration, and then you place shapes within it. Then you can hide the collection of shapes by clicking on the group shape. Then you can click it again to expand the collection of shapes that it contains. So you can think of the group shape as a comment. You can add one to your orchestration to serve as a placeholder for something you need to add later. Or you can use it to add notes to describe what's taking place within it. The name property of a group shape can be up to 511 characters long. And when you collapse the group shape and you're in the designer, you can just hover the cursor over the group shape and it will display the entire name within a tooltip. And then since there is no runtime behavior associated with the group shape, it is just ignored by the compiler at build time. So the scope shape allows you to group orchestration shapes together as well, but this one does implement some runtime behaviors, and rather important ones at that. First, you can use a scope when you want to define variables and messages and correlation sets that must remain local. You don't want them visible to the entire orchestration. After the scope shape finishes execution, all of the memory associated with those objects will be freed up. So you could think of it as something like a block of code in a C# or VB.NET class. And as you might expect, it's possible to nest scope shapes. The second point about scope shapes is that you can specify a scope to be synchronized. By default, it is not. Marking a scope as synchronized is useful when you have parallel branches of code that could be trying to access the same variables. A synchronized scope will prevent one branch from writing to the variables while the other branch is trying to read from the variables. The third capability that scope shapes offer is the ability to deal with non-serializable objects. So what does that mean? Well, since an orchestration state can be persisted to the message box at various points, the orchestration runtime requires that any of its variables must be serializable. In fact, the orchestration compiler will actually report an error if you try to declare a variable of a type that is not marked with the .NET serializable attribute. Well, at some point you may encounter a situation where you absolutely need to use a variable of a class that is not marked with a serializable attribute. So what you can do is you can configure a scope shape a certain way. We're going to talk about the details later in the next module, but you can configure a scope shape to block the orchestration engine from executing persistence. And then you can use that non-serializable object within that scope, and then when the scope completes, the orchestration engine goes about its usual business. The last two capabilities that the scope shape offers are exception handling and transaction compensation. And these are perhaps two of the most important features that the orchestration engine offers. So, to the right, you'll see a simple orchestration with a scope shape in it. And we have a situation where a loan is being processed. And as part of that, our orchestration needs to request a credit report and an appraisal. Now, if either of those operations fails, at a minimum, the orchestration would probably have to report that. So that's where you can add an exception handler to the orchestration. You can add as many of those as you need, each catching a different type of exception. And within the exception handler, define what should happen in the event of a particular error. So in a sense, the scope shape is acting as a try block. Now, while exception handling is a familiar idea to most developers, the idea of transaction compensation might not be as clear. So what does that mean? Well, if you think of it this way, exception handlers instruct the scope shape what to do if something within it fails. Transaction compensation instructs the scope shape what to do if something outside of it fails. What does that mean? Well, after the scope shape has completed its operations, requesting the credit report and or appraisal, it's possible that somewhere down the line, the loan application process for this particular loan might fail. And that could be because the applicant backs out, or perhaps the lender backs out for some reason. Well, what do we do with this credit report and or appraisal? Well, maybe it needs to be archived. You can define the actions that need to be taken to quote unquote undo the completion of this scope. And you do that by adding instructions or shapes to the compensation block. So we'll talk more about exception handling later in this module, and then we will revisit transaction compensation in the next module. Okay, so we can say that scope shapes give us some control over the flow of our orchestration, but that really only applies to exception handling and transaction compensation. So what about the normal flow of things? Well, we have a collection of shapes that allow us to route data and messages through the orchestration process, so let's take a look at those one at a time. The first one on the list is the decide shape. And this looks like a typical flowchart shape that you might see. It lets you implement if-then-else logic. So after you drag one of these onto the design surface for your orchestration, you will need to configure a rule. So you will just double-click on that rule shape and enter an expression. In this case, perhaps it's checking if the quantity is greater than 1,000. If the expression evaluates to true, then the branch beneath the rule shape will execute, otherwise the branch beneath the else shape will execute. So it's possible to add additional branches to this decision shape. Each of the additional branches will have a rule or expression of their own. And you add a branch by right-clicking on the decision shape and choosing Add Branch from the context menu. And by the way, a branch can be empty if that's what your process requires. Next on the list is the delay shape. Maybe the orchestration received a message indicating that a work order had completed, and the policy for this business process is to place a follow-up call the next day to make sure that the work had been completed satisfactorily. You could use a delay shape for something like that. So when you add a delay shape to your orchestration, one of the properties that you will need to provide is an expression that returns either a time span with a relative time, so expire, in other words, 2 hours from now, or an absolute date time object. So I want this delay to end next Tuesday at noon. So the delay shape can be useful all by itself, but it's quite often used in combination with the listen shape. So the listen shape is really pretty cool. It allows you to wait for one or more messages to arrive in the orchestration. And whichever message arrives first triggers execution to continue. The subsequent shapes in that branch will execute, and then the listen shape will move on. So you can add additional branches to the listen shape simply by right-clicking and then choose Add Branch, the same as you do with the decide shape. There is a constraint, however, with the listen shape that this picture doesn't show, and that is that the first shape in each branch needs to be either a receive shape or a delay shape. So that opens up the possibility of defining a timeout. So for example, if the orchestration scenario I mentioned sent out a message that a follow-up call was required, it may wait for 12 hours for some sort of a response to that. So in one branch, it may wait for a confirmation that the call was placed. And another branch might be listening for a message that the call is still pending. The client never answered or a voicemail was left. And then in the third branch, we could add a delay shape saying that we want to wait for this for 12 hours, and if nothing happens, then we need to continue execution, and perhaps the next step is to escalate this. So next up on the list of flow control shapes is the loop shape. And this implements a while loop. You configure the loop shape with an expression, and as long as that expression evaluates to true, the loop executes an iteration. When the expression evaluates to false, execution jumps to the shape following the loop. So you just double-click on the loop shape, and you will be presented with the expression editor window. And you can enter an expression. It will look an awful lot like C#. It's got some limitations. There's no increment or decrement operator, for example. It's actually because these keywords are from the Xlang language specification. But the expression editor offers IntelliSense support, and so you will have all of your orchestration variables, all of your messages, and of course with the variable types being classes, IntelliSense will present you all of the class members, whether they be properties or methods. Up next on the list is the parallel actions shape. Now the name of this shape would lead you to believe that all of the branches execute simultaneously. But alas, that is not the case. Each orchestration executes on a single thread, and so that includes the parallel actions shape. In fact, you can even slow down your orchestration by overusing parallel action shapes because the orchestration needs to stop and save its state as it reaches the end of each branch. Well, what's it good for then? Well, if you think back to the listener shape, in that case, an orchestration could be waiting for multiple messages to arrive, and as soon as one of those messages arrived, execution continued. The parallel action shape, on the other hand, requires that all branches complete before it continues. So in that case, you may have a situation where you require 2 or more messages to arrive in any particular order before the orchestration can continue. So perhaps our business process requires that 3 messages need to arrive before anyone can be sent out to complete a work order. So perhaps our orchestration needs to wait for a message confirming the date and time at which the work should be completed. It might need to wait for a message indicating that the site is ready. It might need to also receive a message indicating that tools and materials are available to complete the work. And only after it receives those 3 messages should it continue and dispatch someone to go complete that job. So the parallel action shape is really intended to handle those situations in which an orchestration needs to receive multiple messages and it doesn't know the order in which they will arrive. And we're going to revisit that in Module 15. So we talked about the scope shape having the ability to handle exceptions. Well, what do we do in an exception handler? Well, in some cases, it would make sense to suspend the orchestration. Perhaps we send out a message indicating that an unexpected condition occurred, but we don't want to throw out the orchestration and all of the state that it contains, but we really don't have any other work to do either. So what we could do is we could suspend the orchestration. It will show up. So when the orchestration is suspended, it will show up in the BizTalk administration console, and an administrator can see what the message is saying. So revisiting that work order example earlier, where the orchestration sends out a message for a follow-up call, if it doesn't hear back about that call, it escalates or sends the message off to another manager, and perhaps it waits for a response there. At some point, if it's not getting any response, it probably doesn't make sense to loop indefinitely. Maybe these messages just aren't getting out. In that case, it could make sense just to suspend the orchestration and let an administrator check into it and see what's going on, see if it's a technical issue. Now, if things really go bad and you need to notify an administrator, you could add a terminate shape. So maybe you add one of these inside of an exception handler. And the terminate shape allows you to return a string. So it could even be the exception that you've caught. You extract a string value out of that exception object, plug that into the terminate shape, and let the terminate shape end the orchestration and report that to the administrator. Now, you don't want to just use these anywhere that you just want to jump to the end of the orchestration, because these are going to be reported as errors. And if your orchestration should just complete normally, the terminate shape is going to interrupt that. So you could think of a suspend shape as something like a warning, and a terminate shape as something like a error or a critical error. So two of the other shapes that you might find useful are the expression shape and the throw exception shape. So the expression shape is really powerful because it allows you to add lines of code to your orchestrations. So you add one of these on the design surface of your orchestration, wherever you need to execute a few lines of code, and you get access to your variables. So you start concatenating strings, adding numbers together, and so forth. And you will be able to edit these expressions in the expression editor, so it will give you IntelliSense support. But one of the really cool things is if you have a class of your own that you need to make use of, you can use the expression shape to do so. So just make sure the assembly containing your class has been deployed to the GAC, add a reference to it in your orchestration project, and then declare a variable of the type of your class, and then you can start calling methods on it. If your class is not marked serializable, of course, you'll need to play the little trick that I mentioned earlier with the scope shape, but we're going to talk about that in more detail later in the next module. But another technique around that is if you're using static methods, you can simply call the static methods directly, and you don't need to worry about declaring variables and about serialization. And on top of all of that, it really can get powerful if you need to pass a copy of a message from your orchestration to your method. You just need to make sure that your method accepts an XML document as a parameter. And then in the expression where you're making the method call, just pass the message variable from your orchestration, and you'll be able to open that up if needed in your custom code. Now with the throw exception shape, last time I mentioned exceptions, I was talking about the ability to handle those. So considering that we tried to send a message out, something failed, and an exception was thrown, we can use the scope shape to define those exception handlers, and we're going to get a chance to do that. On the other hand, we might encounter conditions, perhaps when we're executing an expression, or we get a result back, or we execute a decide shape and determine that something isn't right, and we need to report that as an exception. What you can do is you can use the throw exception shape, but what you'll need to do before that is you'll need to declare an exception object. So you'll need to declare a variable of a type that derives from system.exception. And then you'll need to use an expression shape to initialize that variable, populating it with whatever diagnostic information you so choose. And then you add the throw exception shape, passing that exception, and then the exception handler code that you define will be able to catch it and process it. So some of the business processes that you work with might share some common functionality. So rather than implement that multiple times, you might just want to factor that out into a separate orchestration and call it. And the good news is that BizTalk supports that. So there are two ways to go about this. You can make a synchronous call. So when you set up an orchestration to be called by others, you can define parameters on it. So you can define in parameters and out parameters and pass by reference. So that way you can receive information and send information back. So you set this up by creating an orchestration that can be called. So that will not have an activating receive shape at the top. It will simply be expecting to receive the information it needs passed as parameters to it. Once you have that orchestration complete, then you go into the orchestration that needs to make the call, and you add a call shape. And then you configure that call shape with the name of the orchestration that it needs to call, as well as the variables that will be passed in as parameters. Then at runtime, when the orchestration runtime hits that call orchestration shape, it will create an instance of that new orchestration and pass the parameters to it and wait for it to execute, and then control will pass back to the caller, and then the caller can complete. So this call orchestration shape turns into a literal method call. There is no message box activity between these two orchestrations. One calls the other. So that's what you need to do to invoke another orchestration synchronously. Now you do have another option. and that is known as the start orchestration shape. So in this scenario, your orchestration is going to start another orchestration, and then your orchestration is going to immediately continue processing, and it's not going to wait. So you're making an asynchronous call. As in the previous case, you can pass parameters in, but since you don't know when that second orchestration is complete, you cannot expect it to pass parameter values back to you. So when the orchestration engine hits a start orchestration shape, it is going to take all of those parameter values and submit those to the message box. And then it's going to create a new instance of the orchestration that is being invoked, and it's going to pass those parameter values. And that orchestration will begin running. The original orchestration will continue running, and it may even complete first. And then at some point, the invoked orchestration will complete as well. So these can complete in any order. And this, by the way, is the technique that you can use to accomplish parallel processing. So if you have operations that need to be processed in parallel, you can call start orchestration for each one of them. And each of those orchestrations will execute on its own thread. The hard part, of course, is that the start orchestration won't help you collect everything back together when it's done. So your application design will need to account for that. Well, now that we've had a chance to see some of the additional shapes that are available to us in the Orchestration Designer toolbox, let's see how we can actually put them to use. One of the things we will typically need to do within an orchestration is to access fields within a message. We've seen the ability to promote property fields, and we've used those in the past. When we work with the orchestration runtime, we have another option, and we can define distinguish fields, which offer some advantages. So I'll show you how to define some distinguish fields, and then I'll show you how you can make use of those within your orchestration. I will also show you what you need to know to create expressions, and then I'll talk about correlation and the steps that we need to take to configure an orchestration to accept a response to a message that it had sent out earlier. For example, in that work order scenario I mentioned earlier, the follow-up call was sent out, and we need to accept the response messages in up to 12 hours later. Obviously, we can't hold a TCP connection open for that long, waiting, so we need to come up with another means to match inbound and outbound messages. Then I'll show you what that looks like in Visual Studio, and then finally we'll close by talking about exception handling. Now, within an orchestration, the body of a message is more or less opaque. You can access message context properties easily enough, and that's about as efficient as you can get because the property fields are parsed by the incoming XML disassembler pipeline, and that is a streaming reader, so it can read those values very efficiently and add those to the message context. And the orchestration has easy access to the message context, so it can access those variables efficiently. So what happens then if you need to access a field that has not been promoted as a property field? Well, it is technically possible to perform an XPath query on a message within an orchestration, but that is very costly. And that's because in order to perform the XPath query, the orchestration engine is going to have to go to the message box, retrieve the body of the message, open that up into an XML document in the DOM model, execute the XPath query. Then we'll have to discard the XML document object, and all of that can get really expensive in a server environment, especially under heavy load with larger messages. So a better approach is to use these things called distinguished fields. So you can define a distinguished field by going to the BizTalk schema editor, and you promote an XML element or attribute as a distinguished field. And then it's very easy to access it within an orchestration. You simply use dot notation, for example, message order dot discount. One thing that's different about distinguished fields is they do not need a property schema. They will always assume the name of their corresponding XML element or attribute. And the data type is taken from the definition of the XML schema. One of the limitations of distinguished fields is that you cannot use them as a basis for a subscription. So for example, you could not include a distinguished field in a filter for a send port. And that's because the BizTalk message engine ignores distinguished fields. It only pays attention to property fields. So distinguished fields are actually written to the message context. They are just not flagged as property fields. So only the orchestration knows how to make use of them. One of the big advantages of distinguished fields is they do not have the length limitation that property fields do. Property fields are limited to 255 characters, and that length limit is imposed by the messaging engine because it needs to do string compares to match messages with subscribers. So distinguished fields have no limit, it's just limited by system resources. So here's an expression that makes use of a property field and a distinguished field. This expression accesses the total order amount property field from the order message, and then it accesses the discount distinguished field from the order message, and it multiplies those two together and assigns that value to an order total variable that belongs to the orchestration. In this demo, we will revisit the process order cache orchestration, and we are going to add a rule to check the order total. And if the order total is greater than 2000, the order will need to be sent for manual approval. To implement that, the orchestration will need access to the order total field, and then I will add a decision shape to the orchestration to check the value of the order total. In order to get access to the order total field from within the orchestration, I'm going to promote the order total node as a distinguished field in the sales order schema. All right, well, the first item on the agenda for this demo is to promote a set of properties on the sales order schema. So let's open that schema and expand it. All right, we're going to promote the comment, the order total, and the order number fields as distinguished fields. So let's click promote and then show promotions. You can see we don't have any distinguished fields promoted yet, but we do have some property fields. The order type and the customer name are already promoted. Let's set up the distinguished fields. These will only be accessible within our orchestration. So we'll promote the comment and the order total and the order number. Okay. Well, let's close that and save the changes. And then let's build the solution so that these distinguished fields will be available when we're working within the orchestration designer. Okay, that looks good. The next step is to open the process order cache orchestration, and we'll update the comment field to indicate that the order has been processed. So we'll use the new comment distinguish field to do that. Okay, that comment value is set down here in this build complete message assignment shape. So you can see that we're making a copy of the original sales order message to create a new sales order complete message. Now, if we want to make modifications, we need to do exactly what we're doing here, and that is make a copy of the message, and then we can alter the copy. All right, well, let's set the comment. You can see here that this line of code uses the distinguish field notation. So it's just the message name dot distinguish field name, and then we use that just like any other property on any other object. So we can just assign this string to indicate that this order is complete. So it's very easy to access distinguished fields within an orchestration. Okay, well, that looks good. Now the next thing that we need to implement is we need to add a decide shape to determine the size of the order. Orders that have a order total greater than 2000 need to be approved before they can be processed. So let's add a decide shape here. All right. And let's call this decide shape the order size decide shape. Okay, now let's implement the condition, and this will be the rule branch for our large order. Okay, let's add the expression. So you can see here again, we're using the distinguish field notation to access the order total. And here we're checking to see if the total is greater than large. And if so, then we expect that this branch will execute. Okay, well, if it's a large order, we need to send that order out for approval. So to do that, we need a send shape. So let's configure that. We'll call that the send approval request shape. And then the message we need to send is the sales order message. Okay, so far so good. Now, we need to wait for a response, but we don't want to wait forever. So the next thing that we need to do is to add a listen shape. And so we can configure that listen shape to wait for a response message, but we can also configure it with the timeout. So let's make that happen. All right, we'll insert the listen shape here. And we'll call this the listen for response shape. You'll notice that we have to either add a receive shape or a delay shape to the first position in a branch. By the way, only one branch is allowed to have a delay shape. So let's add the receive shape first. And let's call that the receive order approval shape. And that is going to receive the approved message. Okay. Let's configure the timeout for the listen shape. So we'll do that by adding a delay shape. And we'll call that the wait for approval delay shape. And now, once again, we need to add an expression. And so this expression needs to return a time span object or a date time object. So in this case, we will return a time span object that consists of 30 seconds. So this delay shape will expire after 30 seconds. All right, well, what do we do if the delay expires? Well, we don't want to throw this entire thing away. So let's suspend this orchestration. And let's call this shape the timed out shape. And now we can provide an error message to indicate what went wrong. So let's indicate which order number did not receive approval to proceed. Okay, so there we are, providing the order number in the string format. So it will be substituted in the position with where the curly braces are. All right. Well, we've got the basic flow all set up. So now what we need to do is we need to create the logical ports for sending and receiving these messages. So let's configure a new logical send port. Let's call that the request approval send port. And that port should use the existing sales order type. Okay, this will always be sending messages. And we'll choose the specify later binding option and then finish. And now we just need to connect that to the send shape. All right, now let's add a receive port to accept the approval. We'll call this the receive approval port. And then we'll use the existing port type for the order approval type. Okay, we'll be receiving. Click next and finish. And then finally we can connect that to the receive shape. We're going to revisit this orchestration. We need to talk about a couple of other things before we're ready to build and deploy this. So let's come back to this orchestration in just a few minutes. I mentioned the expression shape a little earlier, and I mentioned that expressions offer a lot of power. So let's revisit those and talk about expressions in a little bit more detail. There are a few different places in which you can use expressions in your orchestration. One of those is at the very beginning of the orchestration in the receive shape. And you can take control of the filter expression that's used to set up the subscription for your orchestration. By default, your orchestration is going to subscribe to messages that arrive on a particular port that you configure. And it is also going to watch for messages of a certain type, and that type is determined by the port type that you define for your receive port. And in a lot of cases, that default subscription will suffice. But in the lab that you're going to be doing for this module, you want one orchestration in your application to pick up cache orders and process those. And then you want a separate orchestration to pick up only credit orders and process those. So you are going to add an expression to your receive shape to check the order type property to see whether the value is cash or credit. Now, since you are going to be using that as a subscription filter, you will need to be checking, of course, the property field that represents the order type. You also saw another use of expressions in the previous module, and that was in the message assignment shape. And in that case, you were copying the body of one message to the other, and you actually copied the entire message context from one message to the other as well. And that's a pretty common thing to do. You will frequently find yourself using expression shapes to access the values of variables, getting and setting those values. And in a similar vein, you will, of course, be using expressions in decide shapes and loop shapes. We haven't really explored dynamic ports or dynamic binding in detail. We're going to do that in Module 15. But you can use expressions to initialize those dynamic ports. So if you need to send a email out, for example, just prior to sending that message to a port, you can configure the email address on the dynamic port object. And then when the message passes through the port, that email address will be used as the destination. And as I mentioned earlier, the expression shape allows you to call any .NET objects of your own. In the last demo, I set up a send shape and a receive shape. And so we need to think about the consequences of that a little further. If we're just going to call a web service, we're all set. All we have to do is set up a send receive port, a two-way port, send the message out, and the response will come back. However, if we send the message out and we expect that the bank will contact us later after they've had a chance to actually process the loan, we're probably not going to get that response message back in just a few seconds. So you'll frequently encounter situations in which an orchestration sends a message out and then it receives the response back much later. Could be hours, could be days. So obviously, since we can't open a network connection that long, what are we going to do? Well, we need to provide the orchestration a means to match that incoming response with the message it sent out earlier, and that's known as correlation. So you'll need to set up a few things to get correlation to work. One thing you'll have to do is you'll have to define a correlation type, and the correlation type specifies the set of message context properties, the property fields that the orchestration engine should use to match up the request and the response messages. And then once you have that set up, then you need to create a variable of that correlation type. So that variable will be known as a correlation set. And then once you have that correlation set, then you need to configure your send and receive shapes to make use of it. So let's take a look at this animation that illustrates all of this. So when the right time comes, the orchestration is going to send a message out to the bank, notifying them of this new loan. And with correlation set up, the orchestration engine is going to create what's known as an instant subscription. This receive shape is going to wait for a very specific message coming in. So rather than just saying, I am going to receive a message on the bank confirmation port that is of type confirmation, it is going to watch for a specific confirmation. So in this case, it may be a customer number and a loan number. Whatever information that we can make use of that is common to both the message going to the bank and the message coming back from the bank. So with this instance subscription sitting here waiting for a very precise set of message context property values, when that message arrives, it will be delivered to the orchestration, and then that instant subscription is discarded. So to make that work, you'll have to define the correlation type and then the correlation set variable. And the thing you need to do to the send and receive shapes is you need to configure the send shape to be initializing that correlation set variable. In other words, populate that variable with the values, the customer number and the loan reference number, so that the orchestration has the information it needs to set up this instance subscription. Then you need to configure the receive shape to let the orchestration engine know that it is waiting on an instant subscription, and you do that by configuring it to follow the correlation set that you initialized in the send shape. And the reason this receive shape is not an activating receive shape is because the orchestration would have already been instantiated somewhere up the line. So once you have everything configured, you can rely on the orchestration runtime to execute the correlation for you. In the last demo, I added a send shape to send out a order for manual approval, and then a receive shape to receive that approval, but I did not set up correlation, so I'm going to revisit that and create a correlation type, and then declare a correlation set variable of that type, and then configure the send shape, sending out the request, to initialize that correlation set, and then I'll configure the receive shape to follow that correlation set. In the last demo, we had a send shape that sent out a request for an approval on a sales order, and then we had a receive shape that accepted the approval response. So now let's implement correlations so we can tie those two messages together, the request and the response. Okay, so here we have the order approved schema. Let's open that up. And it has a field named the reference number. So this is just going to contain the order ID of the original sales order. So let's promote that reference number to a property. We'll use the order ID message context property that's been defined for this application. And now we need to do the same thing in the sales order schema. Now the sales order schema does not have a reference number property. It instead has an order number property. Now you'll notice a couple of things. First of all, the order number property is already promoted as a distinguished field. And then second of all, the order number property does not have the same name as the reference number property in the approval schema. It's perfectly legitimate to promote a field as both a distinguished field and a property field. There's no real benefit in promoting a property both ways in a new application, but over time you'll find that it can happen with changes being made for maintenance purposes. Alright, well, let's go ahead and promote the order number field. And we need to promote it to the same message context property that we are going to use for the approval schema. So we're going to promote this to the order ID message context property. Okay, we have the schemas configured. Let's build the project so that these updates will be available to the orchestration designer. And then let's open the orchestration and implement the correlation. The first thing that we need to do is we need to define a new correlation type. And the correlation type is going to specify which message context property or properties should be used to relate these two messages to one another. Okay, so we'll just create this new type. And the first thing that we're presented with is a list of possible message context properties. So we can choose multiples, but in our case, the order ID property will suffice. So let's add that to the list, and then click OK. Okay, let's give this a more meaningful name. Okay, now that we have the type defined, we need to create a variable to actually hold the correlation value. So let's go create one of those, and that's called a correlation set. Let's set the properties on it and give it a name, and then we choose the type. And then it automatically knows, based on the type we've chosen, which field or fields will be used for the correlation. Okay, now we need to go to the send and receive shape, and we need to configure those. So we need to set that correlation variable as the message is being sent out through the send shape. And so we do that by setting the property on the send shape. and that is the initializing correlation set property. So we might have many correlation sets. We just choose the one in this case that we're going to use. And then on the receive shape, we need to specify that this is weighting based on a certain correlation variable. And we do that by setting its following correlation set property. And notice that this is not an activating receive shape. The orchestration will already be up and running by the time this receive shape executes. Okay, we can build this solution. And now we're ready to deploy and test it. Okay, so I have deployed the orchestration out to the runtime environment. So let's see how this correlation works at the BizTalk runtime level. So we've got a couple of sample data messages out here. Here is one sales order, and this is a sales order that does not exceed the limit. It does not require approval. And then this sales order does require approval. Its total is greater than 2,000. Okay, so take note of that order number. We're going to see that in just a second. One more time. Here's the approval message that corresponds to that order number. And there you see it. So that's the same number as the order. And so if this message is sent in, that will allow the sales order to go through. Okay, well, let's send these two orders through and watch what happens. There's nothing in the out folder. Okay, I'll drop these into the input folder. BizTalk has picked them up. And you can see that we have one order that completed, and then the other one requires an approval. So let's quickly drop the approval message in before the delay shape expires. And we made it in time. So you can see that the other order completed as well. So let's open these messages one at a time. And so we can see that this is the order for 3,000 and that processed complete. And then also this is the message for the smaller order, and that one completed as well. Okay, so things worked as expected there. Here is the sales order that was sent out for approval. So you can see that is the order, that's the large order. All right, let's delete these and try this one more time, but let's let the delay shape expire this time. Before we do that, I'd like to go look at the subscriptions that are in effect right now. And what you can see here, at the top of the list, you see a subscription for the process order cache orchestration. And that's all we have for orchestrations. Okay. So let's drop a copy of the large sales order message in. All right, there it goes. Now let's go look at the subscriptions one more time. Now you see a new subscription in the list for the process order cache sales order. But if you notice, this subscription is different than the others. This is an instance subscription. So this subscription corresponds to a particular instance of the process order cache. In particular, it is looking for a message that's coming in through a specific receive port, and it's got to be an order approval, and it has to match the order ID property that's been set. That's the correlation set variable dictating that value. Okay, so now the delay shape has expired, so you can see that subscription is no longer valid. Let's now refresh the Group Hub page and see what we can find. All right, we have a single suspended but resumable instance. Let's click on that and see what we find. Okay, here we go. It is the instance of process order cache. That's no surprise. If you look over here in the error description, you can see that it's the same string that we created in the suspend shape. That it is waiting for that specific order, and it stopped because it encountered this suspend shape. If we click on the Messages tab, you can see all of the information and state has been retained by the orchestration. It's just sitting there waiting to continue. Okay, let's close that, and now let's resume that instance. Before we do that, let's go look in the output folder. You can see that the approval request message is still sitting there. We never did anything with it. Let's resume this instance, and what's going to happen now is the orchestration is going to jump to the end of that listen shape, and then it's going to complete. Now that might not be exactly what you want in your business scenario, but that's the way this very simple orchestration worked. So let's run this query. We can see that the instance is no longer suspended, and now in the output folder you can see that the order has shown up and it is marked complete. Now let's go back and look at the subscriptions that are in effect. Okay, there's the instance subscription. If we run the query, the instance subscription is now gone, so it is no longer in effect. And if we refresh the Group Hub page, you can see we no longer have any suspended service instances either. So there you have it. That's a quick overview of how correlation works at the BizTalk runtime level. Well, we saw early on in our discussion of orchestrations that it was really important to have a well-defined process for handling errors. So fortunately, the orchestration engine helps us out here by offering support for exception handling. Now, we've talked about exception handling a few times already, but let's spend a few minutes just looking at it a little closer so we can understand how to apply exception handling to our orchestrations. So if the concept isn't already familiar to you, exception handling is an error handling mechanism, and it controls the flow of execution when an error occurs. So what happens is an exception object is created, and that exception object contains information about the error that occurred. So what would trigger an exception? Well, there could be all kinds of reasons. First of all, it might be some condition that you detect in your orchestration and deem it worthy of throwing an exception. Now, you don't want to do this for typical conditions that you might expect in a normal case because exception handling is expensive compared to a simple decide shape, for example. So you might encounter a situation in your orchestration logic. Perhaps you're checking for a value in a field and the value that you receive is unrecognized. It might make sense to throw an exception. And in that case, you could use the throw exception shape to implement that. The orchestration runtime might throw exceptions because it could encounter a transaction timeout, or there might be other transaction errors that occur. It might encounter an exception when you call into a custom assembly, and that custom assembly throws an exception. The orchestration engine will receive that exception object and need to process it. There might be a system exception. If for whatever reason an orchestration can't be persisted to the message box, an exception would be thrown there. And it's also possible that you might make a call to a web service, and that web service might return an error in the form of a SOAP exception. If that occurs, then that exception would be reported to the runtime engine, and your orchestration would have to deal with it somehow. Okay, well, how exactly does it work, and what do we need to do in our orchestration? Okay, we've talked about the scope shape and the fact that it can have exception handlers attached to it. And so say we have a scope shape that's executing, and somewhere along the line it encounters an error. So an exception will be thrown. Now what's going to happen is, if your scope shape has an exception handler that knows how to deal with that type of error, then that exception handler will catch that error, and it will have access to that exception object, and then any code that's defined within that exception block will execute. Well, what's an exception block going to do? Well, it might try a few things. If there's an alternate approach to accomplish this task that this scope shape was setting about to do, it might call another orchestration to try that alternate approach. If that's not possible, it might simply report the error. There might be an error portal or a database or a logging mechanism that you use to report errors, and it can extract that error information from the exception object and send it on. And after it's done this work, it might take that exception and throw it to its parent scope so that its parent scope can handle it as well. So there are a few other things to note about exception handlers. As you know, exception handlers are appended to scope shapes, and scope shapes can have multiple exception handlers. Each exception handler needs to be configured to catch a particular type of exception. And at runtime, if an exception is thrown, the orchestration runtime is going to walk through that list of exception handlers looking for a matching handler. As soon as it finds one, it will execute that particular block of code within that exception handler, and it will ignore all others. So even if there's another handler down the line that could potentially match that type of exception, that one will be ignored. So you want to be careful about the way in which you order your exception handlers. You don't want a more general exception handler near the top of the list because that will intervene and prevent more specific exception handler types from executing later on. When you're setting up your exception handlers, you're going to see an option to configure a handler to catch a general exception type. That type of exception handler is more or less going to serve as a catch-all. The main drawback there is that you won't have access to the exception object that was thrown. Since that type of exception handler can catch anything, it can even catch objects that do not derive from the base system.exception class. So consequently, it doesn't really know what it's getting, and so you just don't get a reference to that object. Now, if your scope shape does not have a exception handler that knows how to catch the exception object that's being thrown, that exception will automatically be rethrown to the parent scope. And if the parent scope does not have an exception handler that's configured to deal with that type of exception, that exception will continue to be rethrown to higher level scopes until ultimately it's thrown to the orchestration runtime, and the orchestration runtime just does its default exception handling. So you'll probably have to think long and hard about how exactly you want to implement your exception handlers. But as we saw earlier, they can add a tremendous amount of value when you're trying to automate a business process from end to end. In this lab, you'll start off with the AdventureWorks solution you've been working with all along, and you're going to implement a new orchestration that knows how to process credit orders. This will look similar to what you saw in the demos, but not exactly. So you're going to start off by promoting a series of distinguished fields, and then you'll make use of those in a new orchestration that you create. And amongst other things, you'll be setting up some orchestration ports. One of the more interesting things that you'll be doing here is you will be setting a filter on your receive shapes. So you're going to have one orchestration that only receives cash orders, and this new orchestration that only receives credit orders. And you're going to handle that by adding a filter to the receive shape. And then once you've got everything built, you can just deploy it out to the runtime environment and try it out.